SN2 causes inversion of configuration at the stereocenter, while SN1 gives racemization unless intimate ion pairs or neighboring group participation cause partial retention. Think of the carbon with 4 different groups like a small merry-go-round with a seat that you can push from the back and flip the rider around, which is what happens in SN2. The nucleophile attacks from the side opposite the leaving group and kicks it out at the same time, so the 3-dimensional order of the remaining groups flips like a picture in a mirror. SN1 is like the rider stepping off and the seat sitting empty for a moment as a planar carbocation forms, so a nucleophile can come from either side and give a mix of both configurations. However, if the departing group and the nucleophile stay close together as an ion pair, or if a neighboring atom temporarily holds the spot, one face may be favored, and complete racemization does not occur. To predict the outcome, ask whether conditions and structure favor concerted backside attack for SN2 or a stepwise, planar intermediate for SN1, and also watch for nearby groups that can shield one side or assist the reaction. Students often assume SN1 always gives an equal 50-50 mix, when in fact ion pairs or neighboring group participation can bias the approach, so look for nearby heteroatoms or aromatic rings that can stabilize or block a face. Another common mistake is thinking tertiary centers cannot undergo SN2. While tertiary carbons are very hindered and disfavor SN2, under very strong, small nucleophiles and special conditions, some substitution with inversion can still occur, so evaluate sterics and nucleophile strength together. Finally, learners sometimes ignore solvent effects and base strength, but polar protic solvents and weak nucleophiles favor SN1, whereas polar aprotic solvents and strong, unhindered nucleophiles favor SN2, so check reaction conditions before predicting stereochemistry. For more examples and video explanations on predicting stereochemistry and nucleophilic substitution at stereocenters, visit www.gumballdegree.com.